Good evening, everybody. My name's Dave Griggs. I'm Director of the Monash Sustainability Institute, and it's my pleasure to be the MC for this evening's lecture. But my main purpose here is obviously to introduce our speaker, Sir Bob Watson. And if I gave you his full CV, then we'd be here for the whole hour, and you wouldn't actually get to hear him. So I'll give a very, very abridged version. Bob is one of the world-leading experts on global environmental issues, and a very wide range of global environmental issues, from climate change to ozone depletion to biodiversity to sustainable development. Some of the positions he's held has been chair of the Intergovernmental Panel on Climate Change, co-chair of the Millennium Ecosystem Assessment. He's been chief scientist to the Department of Environment, Food and Rural Affairs in the UK, chief scientist to the World Bank, scientific advisor in the Clinton White House, and currently he's the UK representative to what's called the Open Working Group, which is a UN group which has been established to negotiate the Sustainable Development Goals by 2016. But most importantly, and most pleasing to me, is that he's agreed to become a Sir Louis Matheson Distinguished Research Fellow of the Monash Sustainability Institute. So Bob has been here for the last 3 weeks, working with us to run a workshop, a national workshop, on sustainable development goals and what that means for Australia. He's received many prizes, including the Blue Planet Prize and many others. So I think we're all looking forward to hearing from him, so I'll stop at that point and introduce Sir Bob Watson.
Thank you. And after that introduction, the talk will be a total anticlimax. Anyway, I've got a lot of slides, but if anyone ever wants them afterwards, Dave will actually put them on the Monash website, and so people can look at them at a bit more leisure. What I want to try and do is talk about where are we in both environmental and development issues, looking at climate change and biodiversity, what's the current state, what are the projected changes, why do we care about the impacts of climate change and biodiversity loss, what sort of actions are needed to realise a sustainable world, and what's the policy process that's occurring both here and in Australia. So the current global situation, which has improved over the last 15 or 20 years, but still unacceptable levels of poverty, 1 billion people still living on less than $1.25 a day. Income inequality is growing. Levels of hunger, 1 billion people go to bed hungry every night. Complete lack of access to clean water, which has got better in the last 10 or 50 years, but and lack of modern energy. 1 billion people that still have no modern energy. The way we produce and use our goods, totally unsustainable. Our economic system is still unsustainable, and we're seeing environmental degradation regionally and globally. So what would a world that is sustainable look like? Well, we'd want a world without poverty. We want to eliminate income poverty. We want a world free of hunger, access to clean water, access to modern energy. We want to be healthy, educated. People want to have voice and participate in decision making. However poor they are, they want to help guide their own future. They want to be secure, have access to sexual reproductive services. They want to have property rights like most of us have. And we need a world that is environmentally, socially and as economically sustainable. It needs to be ethical. It needs to respect human rights. And we need to get to grips with issues like climate change and biodiversity, which are not just environmental issues, but they are development issues. This is totally achievable. But unfortunately, currently, the current system is flawed, and we're not on that pathway. So what do we know about climate change? No question, we humans are changing the composition of the atmosphere. We're putting greenhouse gases into the atmosphere, carbon dioxide, methane, nitrous oxide. They warm the planet. We're also putting sulphur gases in that turn into little aerosol particles, and they luckily partially offset the warming, so they tend to cool the atmosphere. What are we seeing? We're seeing warmer temperatures, changes in precipitation, changes in sea level, change in Arctic sea ice, changes in Greenland ice. We're seeing more frequent extreme weather events. The world is indeed changing, and largely because of human activities. This just shows you what's happened to carbon dioxide emissions, and they're clearly going up. And as you can see, they've continually gone up from 1960 to the current period. This has resulted in the atmospheric concentration of carbon dioxide going up. This is the so-called Mauna Loa record. The interesting thing about this, that's how it works. We actually, in 1992, we signed the convention to try and protect the climate system. Look, the increase since we told ourselves we're going to protect is actually a faster rate of increase than before. We literally have done nothing to protect ourselves against climate change. This simply says we know it's largely due to human activities. The black line are the observations of surface temperature in North America, Europe, Asia, globally, or global land, global ocean. We put theoretical climate models together that only allowed for natural changes in our environment. Changes in solar radiation, changes in volcanic activity. It's the blue line. And as you can see, the blue line does not simulate the observed black line. We then ran a climate model, very sophisticated, putting all of human activities, greenhouse gases, aerosols, land use change, etc. And as you can see, the pink model simulates both regionally and globally what we've observed. This was the information that the Intergovernmental on Climate Change said most of the observed changes since the 1950s are largely due to human activities. What will happen in the future? Well, we don't know what the emissions of greenhouse gases will be. They're dependent on demographic change, number of people, choice of technology, economic growth, socio-political considerations and cultural considerations. Will we drive big cars or small cars? Will we live in large houses or small houses? So we don't know what it will be. The Earth has warmed about 0.8 degrees Celsius today, and we project another 1.2 to 4 point something, actually 5 point something in the next 100 years. So relative to pre-industrial, we'll expect somewhere between the 2 at the bottom end and 7 at the top end change in the Earth's mean surface temperature. But the key question is not what's going to happen globally, but what will happen locally. So look at the maps. What we learn from the maps is land areas warm more than the oceans. The more red it is, the more it warms. And the high latitudes warm more than the equator. This is what we call low emissions, medium and high. The interesting to see is in the maps of 2020 to 2029, the maps look the same. They are. The climate change in the next 20 to 30 years is already preordained by the emissions we've put into the atmosphere over the last 50 to 100 years. So not only has the Earth already started to warm, future warming is absolutely inevitable, whatever we do to try and reduce greenhouse gas emissions. Therefore, we need to adapt to a changing climate. By the 2090s, however, there's a big difference between a world of low emissions, medium and high. As you can see in the high emissions world, most of the continents are warming 5-6 degrees Celsius or more. So we need to clearly reduce our greenhouse emissions that are projected for the future to try and realise this sort of world rather than this sort of world. We also need to care about precipitation. Much harder to project, but the general picture, and this is December, January, February for the globe, this is June, July and August. The high latitudes in both hemispheres will get wetter, and the subtropics will actually get drier. This is perverse. The areas that are dry today, the subtropics, will get drier, and the areas that are wet will get wetter. Now the question is sea level rise. A document I chaired in 2001, the Intergovernmental Panel on Climate, predicted from 1990 through to 2010, this would be what would occur. What the satellites are showing us is this line, not this line. In other words, sea level rise is getting faster than we actually thought it would. And part of the reason is we underestimated the contribution of the melting of the Greenland ice sheet. IPCC in 2007 felt that the range of sea level projections would be somewhere between about 20 and 60 centimetres. All the recent estimates in the last year or two are more suggesting at least a 1 metre sea level rise, with uncertainty, of course, a 1 metre sea level rise by 2100. This could be really serious for low-lying deltaic areas and also for small island states. Parts, not all, parts of Antarctica are clearly melting, contributing to sea level rise. Greenland, literally all of Greenland last year, this was the ice cap on July the 8th, on July the 12th, literally all of it was subjected to some level of melting. much faster than we ever predicted even 5-10 years ago. Arctic sea ice is going down. This is the sea ice in March, the beginning of the summer period, and as you can see, it's gone from about over 16 million square kilometres down to more like 14.5. But even more worrying is what happens in summer. This slide here, as you go from June, July, August, September, you get melting of Arctic sea ice, and it will typically go down from about 12 kilometres at the beginning, 12 million square kilometres beginning of June. Typically, the average between 1979 and 2000, it'd go down to somewhere like this, somewhere around 7. Last year, 2012, it went to here. Less than 4 million square kilometres, less than half of the average from 1979 to 2000. This is why many of the scientists believe that in the next 20, 30 years, the Arctic might become free of ice in summer. Also, it's not only the aerial extent that's changed, the volume is way lower. It's much, much thinner. So major changes in Arctic sea ice, significant changes in storms. The blue is the sea surface temperature in the Atlantic, and as you can see from 1960 to 2000, it's gone up. Yes, about a bit less than 1 degree, but it's gone up. But if you then look at the red line, this is a measure of the intensity of hurricanes. It correlates perfectly with surface temperature. Most likely in the future, we may not have more hurricanes, but they'll be much more intense, causing more destruction when they hit land. Not only should we care about climate change, but as we put more carbon dioxide into the atmosphere, some stays in the atmosphere, some is absorbed by the forest and vegetation on Earth, and some is absorbed by the sea. So as the atmospheric level of carbon dioxide goes up, it's absorbed into the ocean, and it makes it more acidic, carbonic acid. So the oceans are getting more and more acidic. The current thinking is, if we want viable reefs, the total atmospheric concentration of CO2 shouldn't be allowed to rise above 350. I've already told you it's already 400. Reefs could potentially stop growing at 450. I think we're well on our way to 450 and above. And the coral reefs will start dissolving, so the theory currently says, around 550. My personal view, and I'll talk about it later, I think this is where we're aiming for. If so, countries that really depend on our coral systems, many small island states, for tourism and also for fisheries, have really got a challenge. Also, the Great Barrier Reef, extremely important in Australia for tourism, fisheries, and of course, just its ecological value could also be in real difficulty if this sort of world is realised. So, what's happening to biodiversity? Well, first, what is biodiversity? It's a term that not everybody understands. It's simply the variety of life. Genetic variability, species variability, different types of ecosystems, forests, mangroves, coral reefs, grasslands, so little pictures of different types of biodiversity. A document I co-chaired called the Millennium Ecosystem said, what are the threats to biodiversity? Habitat change, changing a forest to an agricultural system, climate change, invasive species. In other words, bringing species from one part of the world to another part of the world, either purposefully or accidentally, overexploitation, overfishing, overconsumption of the terrestrial biosphere, and pollution of nitrogen, phosphorus, and sulfur. We then looked at some forest systems, dryland systems, some aquatic systems, mountain polar systems. We simply said, what were the major drivers for change in the last 100 years? So if the box is red, a very, very important driver. If it's a very light yellow, it wasn't particularly important. So for tropical forest, temperate grassland, habitat change, the conversion of the forest or the conversion of the grassland was a major change. Loss of tropical forest, loss of temperate grassland. In fact, we've lost probably over 90% of temperate grassland. If you look at climate change, most of them are very light yellow. Not a big issue over the last 100 years. But then we said, well, what will happen in the next 100 years? If the arrow's going up, it means a very, very rapid increase in the importance of that driver. If the arrow's going down, it probably says it'll be less important in the future. Climate change, every arrow going up. Pollution, every arrow going up. If we don't get to grips with human-induced climate change and regional pollution of nitrogen, phosphorus and sulfur, our ecological systems will be heavily, heavily stressed by these drivers. Now, we've seen 5 mass extinctions in the last 500 million years, 500 million years. We are now going through number 6. These are all natural. Number 6 is human-induced. This is the natural rate of evolutionary change. For every 1,000 mammal species, less than 1 would go extinct every millennium, based on the fossil record. This is us in the current time. We're already at least a factor of probably 100 greater, maybe 1,000 greater than natural evolution. And this is what the Millennium Ecosystem projected for 2050, even another factor of 10 or another factor of 100. We humans are causing the extinction of species, and these are just 4 of the projections. By 2050, 18 to 35% of all species committed. They won't go extinct by 2050, but the habitats will not be viable afterwards. Some will die out quickly, some over tens of years, some over 100. This one, 20 to 30%, 40%, 10%. Whatever number, even the low one basically, is serious. So even if these numbers are too high, and there's no evidence they are too high, we've got a real serious issue of losing species. So how do I look at climate change? How does the scientific community look at climate change? And biodiversity loss and ecosystem degradation are not only environmental issues, they're development issues and security issues. They undermine food, water, energy security. They undermine the economy. They undermine our ability to alleviate poverty. They undermine human health, and they're a risk from a security standpoint. We also have to recognise they're both inter- and intra-generational equity issues. Unfortunately, industrialised countries have caused most of the problems, but it's developing countries and poor people that are the most vulnerable. And clearly, the actions of today will not only affect ourselves, but it'll affect future generations. So what are the implications of climate change? Significant adverse effects, as I've already indicated, on ecological systems, especially systems such as coral reefs, but not only coral reefs. Agricultural production for almost any warming in the tropics and subtropics likely to go down. We're already seeing evidence of that in Africa. Now, in a temperate climate, much of Europe, North America, parts of Australia, for a 2 to 3 degree warming, it may actually be beneficial. You get a longer growing season. After 2 or 3 degrees, even in temperate latitudes, probably will have adverse effects. Climate change will have adverse effects on fisheries. Therefore, we're threatening food security. There'll be decreased water availability and water quality in most arid and semi-arid areas, and most areas of the world will effectively have the risk of both floods and droughts. So we've got a water security problem. No question, especially in much of the tropics, there'll be an increase in vector-borne diseases such as dengue and malaria, an increase in waterborne diseases such as cholera. There's also a potentially an increase of heat stress mortality, a significant issue in Europe and North America. If indeed we have less agricultural productivity, there might be threats to nutrition in developing countries, all adverse effects on human health, and especially in some developing countries such as sub-Saharan Africa, where there's not good healthcare facilities, let alone health insurance, and human settlements in river basins and in the coast could be threatened by storm surges, coastal erosion and sea level rise. How have we done on the hunger issue? Food security, a critical issue to people. Well, in one way I could say we've done well. In 1970, 24% of people went to bed hungry, undernourished. That actually dropped by the year 2000 to about 14%, but since then stayed relatively constant, including a little blip there due to the food price hike in 2008. So in one way it's good, but look, we've still got over 800 million people, and at this period over 1 billion go to bed hungry every night. This is an absolutely unacceptable situation. We must try and solve the hunger problem. But it's not just giving calories to people. We've given calories to a lot of people, so we have 1 billion people that don't get enough calories and they're undernourished, and we've got 1 billion people, fat people, they're obese. So what we need is to make sure we get good calories that are nutritious combined with exercise. We've tried to look at what are the implications of climate change on rice production. This is a model from a place called IFPRI, International Policy Research Institute in Washington, D.C. Very fine spatial resolution. They asked themselves the question, how would rice production, irrigated rice, change over the next 50 years. Some areas we will lose in brown, others will gain. Overall, they felt that global production would go down 27% due to climate change, relative to not having any climate change at all. They then did the same thing for rain-fed rice, a 13% loss of production. And then they looked at it by region, they integrated up that map. And so this is our rice production today in South Asia or in East Asia. That's what we project it would be by 2050 in the absence of climate change, technological changes, etc. So improvements in production. This is it with climate change. You can see climate change knocks out most of the growth that we expected, and here it even projects less rice production in 2050 than even today. So that was done for climate rice. Exactly the same thing was done for wheat, and even bigger effects of climate change on wheat production. They then looked at the impact on food price. This is the food price today for each of these commodities. That's what we project it to be in 2050 in red, just due to demographic change, the increase the wealth change, the increased demand, especially more meat. That's what we think it will be with climate change. In other words, we thought that we would project a significant increase in food price just due to demographic economic reasons, but look, even a bigger increase in climate change. Climate change will exacerbate the price of food. It will make it even harder to meet the hunger goal of eliminating hunger. This just shows you child malnutrition, number of children under 5 that are malnourished, and what you can see, this is today in yellow, that's what it would be in 2050 without climate change. This is what it would be in 2050 with climate change. And in each case, climate change exacerbates the challenge of getting away from child malnutrition. Now, I hope these projections are wrong. I really do. But if they're at all correct, we have a serious issue on our hand. So we really have to focus down on climate change and the implications for food security. Now, with respect to climate change and conflict, if I just simply take deltaic areas, low-lying islands, and say sub-Saharan Africa, some numbers of millions, we don't know the number, but potentially some tens of millions of people, or at least a few million people, will be displaced by sea level rise. Food shortages in Africa, where we've already got food shortage. Water shortages in Africa, where we've already got shortage. Natural resources like forests, coral reefs that poor people depend upon will be depleted. Increased incidence of disease in sub-Saharan Africa, where there's not good healthcare services. Increased incidence of severe weather. What's the implication? These are regions already stressed. They're hungry, they've got poor governance, they've got low incomes. They've got no real capability to cope. So climate change with these other stresses may or can lead to local and regional conflict and migration, depending on the social, economic and political circle. We don't know enough, but we need to study this far more. So why do I care about losing biodiversity or degradation of ecosystem services? They're central to life on Earth. They provide the provisioning services, food, water, food and fuel. They regulate our climate, they regulate floods, disease, water, pollination services. They're culturally important, aesthetic, spiritual, educational, recreational, and they're the basis of soil formation, nutrient cycle. All of these lead to security issues, basic material for good life, health, good social relationship. So if we undermine these services, they adversely affect our sustainability. So what do we need to do? We need to address population and consumption patterns. We need to improve resource efficiency. We need to get the economics right, and I'll talk about that. We need to eliminate subsidies in agriculture, energy and transportation. We need to create markets so a farmer not only gets money for producing food, but he gets money for protecting the environment. We need to address the failures of governance and try and eliminate the power of vested interest. This, to me, is the hardest of all. There are many, many good things going on in local communities at the grassroots level. How do we scale those up? How do we move to a low-carbon economy and adapt to climate change? How do we address the drivers for biodiversity loss and the fact we're degrading our systems? And how do we have enhanced levels of education, training, research and development? Well, the population issue, we're at about 7 billion people today. By 2050, it'll be between probably 9, 9.5, and by 2100, probably between 9 and 10. We know how to address it. We have to go back to the Cairo conference in 1994. We need to educate girls. We need to empower women. We need to make sure we've got good healthcare for children and the elderly, and we need to make modern contraception accessible to all. We know how to do it. Educated women have lower fertility rates than not. We've got to empower women. It's the key to success. On sustainable production and consumption, we must break the link between production and consumption and environmental degradation. We know how to do it with clean, environmentally friendly technologies. If we can break that link, this will allow us to very easily raise the material living standards for the poor to overcome world poverty. But we still have to recognise we don't live in an infinite world, and there are some, the planet is finite, and there are some limits. So we've got to decide how to have clean production, efficient consumption, and live within reasonable limits. I believe we can all have a superb standard of living as long as we change the way we behave, and we've got to get the economics right. Governments have to realise that GDP, gross domestic product, is a measure of economic growth. It is not a measure of sustainable economic growth. What we need to do is measure the built capital in the country, the financial capital, the natural capital, human capital and social capital. If we look at these 5 forms of capital, it gives us a much better idea of whether a country is or is not sustainable. Are we depleting our natural capital? Are we investing in human capital? Have we got the right social capital, the institutions, the rule of law, good government? We need to eliminate these environmentally damaging subsidies, as I've already said. We need to internalise what we call the externalities, the cost of doing business. The cost of coal is ridiculously low. We need to recognise the true social cost of coal is not just the cost of digging it out of the ground and transporting it to a power station. People die of lung disease. That's a healthcare cost on society. We have regional air pollution due to burning coal. That also has a cost on society, and it contributes to climate change. If we put those social costs of healthcare, environmental degradation, the cost of coal would probably be the same or higher than most renewable energies. And we have to understand the value of our ecosystems. Not only the value of the provisioning services in the market, but the non-market value, the regulating services that you don't buy and sell in the market, climate protection, clean water, etc. But we've also got to realise you can't put everything in economic terms. You've got to look at the cultural and shared social values of our ecosystem. So when we think about changing land use, we have to think, what do we get out of that piece of land today? And if I change it, what services do I lose and what services do I gain? And by doing that, you can make a much more rational choice of how you should manage land. We need good governance. We've got serious shortcomings in our governance system at the local to the global level, highly influenced by vested interests who don't want to change the status quo. They're making money in a fossil world. They're making money by degrading the ecosystems. We've got to change that. How? I don't have the answers. But at the local level, public hearing, social audits can contribute to at least transparency. National parliamentary press oversight, extremely valuable, because not all parliamentary systems are particularly democratic. But globally, we really need to find a better way to come to agreement on issues like climate change. The problem is there's a lack of trust between countries and a lack of respect. And we've got to overcome that. We've got to build up respect and trust that we're all working in the same direction. But at the individual government level, ministries of water, of energy, transportation, agriculture, they all need to work together. And even though they're in the same government, they're silos. Equally at the international level, conventions on climate change, biodiversity, land degradation, the World Trade Organization, silos where we've got to break down these silos and work together. Lots of good things going on at the local level. As long as rural communities are empowered, they manage their natural resources really often, really quite well. So we need to understand, how do some of these small community activities become sufficient and sustainable in energy, food and water? And they do it when they're empowered. The question is, are these activities at the local level scalable and replicable from one place to another? So we need to look at these sustainable activities and ask ourselves the questions, Can we replicate them in other regions, and can we scale them up? Partnerships, absolutely critical. This isn't an issue for government to solve. It's not an issue for private sector or for civil society. We all need to work together. We've got to be genuine partners with trust between the various partnerships. We also need totally new approaches to financing. A developing country is never going to get rich if it depends on overseas aid. What it needs to do is get good governance. It will then attract foreign direct investments by the business community. So the challenge is to get good governance in developing countries that will lead to investment. So on climate change, governments have said we need to limit human-induced climate change to 2 degrees Celsius, because if you go above, more and more adverse effects on food, water, ecosystems, etc. Okay, they'll still see effects at 2 degrees Celsius. What will it take? Well, we need to stabilise the atmospheric concentration of CO2 equivalent, that is, you take into account carbon dioxide, methane, nitrous oxide, tropospheric, at 400 parts per million CO2. I've already told you, we've already gone past 400 parts per million of CO2 alone. If I take into account methane and the other greenhouse gases, we're around 500. Luckily, we're also polluting our atmosphere with sulphur that becomes sulphur aerosols, and they partially offset through a cooling mechanism the greenhouse gases. We're today roughly at the equivalent of 400 parts per million if I take the greenhouse gases and I take the aerosols into account. But we're still putting greenhouse gases in the atmosphere at an ever-increasing rate. The third slide I showed you. I think there's no chance of hitting this. I think there's only a 50-50 chance of hitting 550, which will be a 3-degree world, and I think it is not at all unlikely that the way we're going, we're aiming at a 650, 750 world. Why do I say that? Well, between now and 2020, business as usual, if we carry on the same trajectory, we will be emitted somewhere between 55 and 59 gigatons per year of carbon dioxide equivalent, say a value of 56. Governments have promised to take action. I don't see much evidence for it. So case one is governments have promised, but limited action. Case four is governments have promised, and they live up to everything they promised. So if we have case one, which is pretty dire, we're only down to about 54 from 56. If they do everything they promise, we're down to 50. But to get to a 2-degree world, we have to be in this space here, somewhere between basically 41 and 46, with a median value around 44. So even in the best case of 50, we're nowhere near the goal of 44 by 2020, which is why I'm so pessimistic, or one of the reasons, of reaching a 2-degree world. What do we need to do? Transform technologies, put a price on carbon to facilitate the transition to a low-carbon economy, but we need behaviour change at the individual level. Attic insulated houses, attic cavity wall if you've got them, smaller cars, more efficient use of the energy. Business has to become more efficient, and government needs to become more efficient and send the right signals. With respect to technology, I'm not going to go through it, we need to efficiently produce our energy and efficiently use our energy. Electric cars, but built on non-fossil source of electricity. We could go from coal to gas, saves a factor of 2 in greenhouse gases per unit of energy. Renewable energy, a key element, wind power, solar power, etc. We could actually still use fossil fuel, but capture the carbon dioxide before it's emitted to the atmosphere. It's called carbon capture and storage. You capture it, liquefy it, and put it in a depleted oil well, a depleted gas well, or into saline aquifers. And that is a possibility, but we haven't fully proven the technology, and we don't know what the additional costs are. Nuclear, I believe, has to be part of the solution, independent of what happened in Japan a couple of years ago. It was a very old power plant. Yes, there was a meltdown. I believe that the modern nuclear power stations are much more reliable, but it's a very sensitive issue for a lot of the public. And we have to manage our forests and our agricultural systems much better. I don't know why the middle of this failed to come out, but never mind. We need to adapt. These are the 8 elements of an adaptation strategy. They're all risk management. They need information. They need financing. Some things need legislation and enforcement. So there is a strategy. We can adapt, but there really are physical limits to adaptation. A small island state is going to be swamped, whatever we do. There are behavioural limits. People don't like moving from where they are, and so even if they're told they're going to be more flood prone or subject to, say, a wildfire, like some of the unfortunate ones you had a few years ago here in the state of Victoria, there are technological limits. We can protect without any question London through the Thames Barrier, a 2.3 metre barrier, but you can't protect a small island, you can't protect Bangladesh, and there are financial limits to how you do it. So what do we need to do on biodiversity? Not going to go through this, but you need to change the economic decision making. Make sure we value all of the services, remove subsidies, pay landowners to manage carefully, and you need market mechanisms to realise this. This was just something, and I'm not going to go in detail. We looked in the UK, how do we value our ecosystems? We looked to see what did we need, or what do we use? Drinking water, cereals, timber, flood protection. What gave us as well? There were services such as clean water, food production, growing trees, water regulating services, i.e. through mangrove systems, reeds. Now, the value or the cost in the marketplace is also a lot of capital input. How do you collect the food? How do you process the food? How do you transfer it? So what we did a lot of analysis in the UK, the value of our agricultural system, what were the capital inputs, and what was left over is what is the value of the ecosystem services. So we really looked very carefully at how valuable our ecosystem services were. We also said you also have to look at mental health, and you also have to look at cultural values that you can't always put in a monetary system. We also have to integrate considerations about biodiversity and our ecosystem in policy, planning and management. I'm not going to go through it, but it's crucial to integrate the thinking. We need to have influence on behaviour. Just like climate change, there's a lot of things we as individuals can do, or the private sector can do, and so therefore I should knock out the word individual. We need to influence behaviour. People need information to know how to be more sustainable, and we need environmentally friendly technology, low carbon technologies, agricultural technologies that produce and increase productivity but with a lower carbon footprint. On food security, absolutely critical. What we have to do is simply embed environmental, economic and social considerations into our policies, practices and technology. The basic challenge is rural development. It's access to affordable financing for the small-scale farmer. How does he have access to markets? How does he get access to appropriate inputs to improve productivity? We need education empowerment of women farmers. In sub-Saharan Africa, 70% of all farmers are women. We need to have agroecological practices. We may need advanced technologies such as genetic modification, but we must fully understand the risks and benefits, and we totally have to reform international trade. We also need training, education, research and assessment. We've got to have educated people to live up to their full potential. There's no question about that. We must invest in education, and we must be multidisciplinary. It's not an issue of natural sciences or social sciences or economics or engineering or law. It's all of them put together. And therefore we have to act now because there's significant inertia in the socio-economic system. Also, once you have climate change, it takes decades to centuries to reverse the damage. And when you lose biodiversity, it's irreversible. We know enough to act, and if we fail, we will impoverish current and future generations. So where are we in Australia from the policy process? Well, there was a document in May 2011, the Population Strategy for Australia. It got people thinking about these sustainability issues. In October 2012, the National Sustainability Council was established that John Thwaites is the chair of. There's a set of indicators, social and human, natural capital, economic capital, and 2 weeks ago, John released, or the government released, the National Sustainability Council's first report. This is my version, it's not an exec summary, this is my interpretation. You're in great shape in Australia, and I mean that, that's not a cynical comment. You're number 1 or 2 globally on the Human Development Index. That's a combination of social and economic considerations. You've got 3 of the top 10 livable cities in the world, Melbourne, Sydney and Adelaide. You've had strong economic growth in the last 20 years. excellent standard of living for most, not all Australians, increased life expectancy and improved levels of education. But the report also said there's some danger signs. The benefits have not been equally shared. There's some social exclusion issues between the better off and the poor. That much of the growth has relied on extraction of natural resources, and therefore some of the resources are now at risk, especially biodiversity. One's clearly going to have to adapt to climate change, and really quite serious. Productivity was the main increase in product, were really the drivers of economic growth in the 80s and 90s, but in the last decade it's decreased, and it's only the terms of trade, primarily with China, that have been good. Therefore, one has to really work out how to increase productivity. Australia is innovative, one of the best in the world. It's got really good research and development, especially in the university. It's not being translated into business opportunities, and it's a real challenge. And clearly, Australia not only has to think about the global context, but clearly the regional context. Changes in China, India, Korea, Singapore, Malaysia. Real opportunities and real challenges of growth in this particular region of the world. Internationally, we started thinking about these issues of sustainable development in 1992 at the Rio conference. We put together some Millennium Development Goals in 1998 and a plan of action in 2000. It runs out in 2015. Ban Ki-moon has established a high-level panel, all of this is on the web, to advise what should happen after 2015. He also put together the Sustainable Development Solutions Network, chaired by Jeffrey Sachs. The governments in the Rio Plus 20 conference last year have put together an intergovernmental working group to again advise the General Assembly. So we've got several processes. I'm part of this, Australia's part of this, and there's now a financing panel. So lots of things going on. On the Millennium Development Goals, I'm not going to read them out, there's 8 of them. We've made lots of progress in some of them, but in some parts of the world they haven't seen the same progress as, say, China. So economic growth almost everywhere. The hunger problem I've already talked about has not improved in sub-Saharan Africa. What was good is there was a limited number and they were measurable, so you could follow them. But they only applied to developing countries. We didn't look at the trade-offs and synergies among these, and they were relatively short-term and didn't look at the long-term sustainability issues. So what's our challenge now moving forward? Well, it's poverty eradication. It's the integration of economic, social and environmental dimensions. Equally important for a developed country, it's human well-being, livability, environmental sustainability and economic prosperity. It's not just a developing country issue, it's an issue for all of us. These are the elements of poverty that poor people talk about, and clearly one of the goals has to at least to eliminate income poverty. I'm not going to read these. These are all of the issues that are being considered by the Open Working Group: hunger, water security, climate change, education, health, waste and inefficiency, cities, jobs, justice and safety. A large portfolio. We can't have 20 or 30 of these. We've got to focus down on the 10 most important. The Sustainable Development Solutions Network has suggested 10. I don't agree with all of them. Some very good stuff in there. Don't necessarily agree with all. And in fact, Dave Griggs, John and I have sent in 6 pages of comment. But it's a very, very useful document to stimulate debate. And there are some very good ideas in there. Well worth going to the web to look at it. There's been a survey called My World by UNDP. 530,000 participants so far in 194 countries. They were given 16 issues, ranked them. This is both rich and poor countries. Good education, number 1. Better healthcare, number 2. An honest and responsive government, number 3. Jobs, clean water, nutritious food, protection against crime and violence, transport, roads, forests, freedom. I was very, very surprised how low reliable energy at home was. Quite surprised. And clearly climate change didn't make the top 10. Does depend how they ask the questions. Some big issues. What does universality mean? What does it mean having a target for Australia versus China or Nepal or Bhutan or Mali? We've got to face issues such as financing, technology transfer, debt relief, intellectual property rights and trade. All very, very difficult issues. The conclusion is straightforward. There are cost-effective and equitable solutions to address these challenges, but political will and moral leadership is needed and is in short supply. And the changes in policies, practices and technology required are substantial and not currently underway. Thank you.